So we want to begin, but actually, there's a little amount of people out here. So maybe we can attract others to come to enjoy uh, whatever is going to be here. And also, it's like to give me more energy. Actually, I really hate that you were like really spread all over the place, but you. So maybe we can move the seats together. They say like more here. Like community at the end of the day, no? Yeah, more people. Yes, yes. Cool. So one thing actually we can maybe we can attract other folks, and they will say like, "What is happening here? Like, why are they so loud?" Hello, familiar faces. So I have this like bar of applause. Actually, it's giving confidence to the speaker, and also like it's rising energy, and also it's like thought talk in a day, right? So maybe you're a little bit tired, so we can little bit lift all of us together. So the game is very simple. It's I have this bar of applause, so it starts really here low, like hey Yoni, good talk, and then actually it's like rising, and you start to shouting like. Really go crazy, even use your legs, whatever you like. Okay? You ready? Are you ready? You ready? Cool, so let's start. Like, start small. No, come on, come on, come on. Two hands, two hands. Kostya, I see you. Two hands. Let's rise it. Yeah. Yay! Cool. So thank you, and let's start. So if you don't know me, my name is Yoni, or Yonatan. Yoni is the short version. In my life, I'm doing a bunch of stuff, but mainly it's divided in two. I'm part of very fast-growing startup Monday.com. Who know what is Monday.com? Yes, a few of us. Cool. I'm leading mobile team, also recently started leading API team. And by night and weekends, I'm part of huge Android community in the world called Android Academy. We give everyone opportunity to learn Android for free. Basically, we're doing courses from zero to hero. Search our channels on YouTube. And today, we're going to talk about memory. And to talk about memory, actually, I want to start with a quote with one of my favorite persons. Know who it is? Hope so. Everyone knows. Oh, Jesus. Really? Yeah, like maybe because of the skin color. So this is the Bill Gates, one of the fathers of the modern PC. And once he said, like, when they developed one of the first personal computers, that 64 kilobytes should be enough, like, for everything. Like, it's already a huge amount of memory, and how, oh boy, he was wrong. When I started, like, my first experience with the computers was like PC. Who know what it is? People maybe older like me. What? No? What is this? Yeah, I know this is personal computer. It's like very obvious. Thank you, Mr. Captain. And actually, it's 286. It was my first PC, and I was mainly playing games on it. I was like small child, and I was like astonishing by this whole experience, playing the game, seeing these pixels. Something is happening, and back then it had 60 megabytes of RAM. It was like huge deal. And then suddenly, fast forward 2022, we have these fancy MacBooks with a 32 gigabyte of RAM. The world is advancing. And same happened to the mobile, right? So when I just started Android development, I have my first phone. It back then had 192 megabytes, like in overall, for whole things that I wanted to do with this shiny thing. And when I was working on one of the first apps, the huge amount of crashes actually were happening with the out of memory. It was like big deal. The amount of memory was very limited, huge pressure. We had to deal with it like daily in our company. And it was a huge headache. And today we have modern devices With like my Pixel, I think it's like 8 GB. There's even devices with like 12 GB of RAM. Like, huge deal. But wait, 2002, still somehow, out of memory is one of the top crashes that happen in the system. Actually, there is even worse things, like out of memory that happen because they try to throw out of memory. Deal with that. And actually, when you start to look into what was the problem, you notice small tiny thing that there is RAM free. It's like teasing you. Like, yeah, out of memory, but actually there were more free memory on the device. Like almost 2 GB, like 1.5 GB on the free memory device. Like, what? Where's the memory? Why I get this out of memory exception? They're still out of memory free. And the thing is like just a tip of the iceberg of everything like happening with the memory. And when you start to dig into these crashes, first thing you will notice that, hey, there's a growth limit for the application for 268 megabytes in overall. So it doesn't matter if your device have 12, 30, 50 gigabytes of memory, there's still limit for one single app for only 268 megabytes to use. And actually, it's just, it's the tip of problems that might happen to your app. And if you don't take care of it, it's actually going to sink your ship. Your users will be frustrated, and eventually they will uninstall your app. And actually, it's the same thing that happened to us. So I said I'm still part of Monday.com. And when I joined, we were like small team, 2 developers. I was the first team lead to join the team. We rushed very fast forward, like to build more features, to attract more customers. And we had this building block we called board. Basically, you can think about as Excel on steroids with a lot of different functionality. Like you have like huge items, columns, a lot of business logic, like caching and database and live observation, you name it. Like, I think even back then we had like RX, RX1, RX2, and coroutines all together working somehow. Very fancy stuff. And actually, when we were a small startup with a small amount of customers, it worked great, no problems. But then, startups tend to grow, to explode. More customers are joining. For example, Tesla, one of our customers, and they managing entire inventory of the car parts in Monday. So basically, you can think about boards with hundreds of thousands of items, and we need to load it somehow in the mobile. So we start to experience very frustrating, huge amount of loading time, like problems with scroll, with frame rate, losing customers, and eventually also we start to get out of memory. And also when we start to look into our Play Store reviews, we found out that there's a huge amount of people are reporting that our app is sluggish, it's very slow, it freezes, it's like the experience is not really enjoyable. So we have to fix it, obviously, right? We are the engineers, this is what we do. And in order to fix it, actually, we need first to understand why happening, how the whole memory management is working in Android, in order to better understand how to fix it. And for that, we start with basics, with RAM. So who knows what is RAM? Okay. So if you don't know, RAM is basically, so obviously, random access memory, but actually it's the fastest memory available that usually working directly with the CPU. And it's the main thing is very, very, very fast. In Android, the entire, like you saw, like 12 gigabytes. So basically, 12 gigabytes are divided between different parts. So first of all, there's a part that's occupied by operating system itself. It's using RAM. Then also there are other apps that are using our RAM, and also there is a buffer and free RAM. So basically, when we start application, the RAM that's going to be used is this. It's like available RAM out of free RAM and caching and buffers. By the way, you can check by yourself just to go to the developer options, running services, and you will see how much each app is occupying your memory. So when we start application, when we click on this tiny icon, what's happening is that the intent is thrown to the Activity Manager service, and Activity Manager service using something called Zygote. Zygote is basically the one that's managing all processes in the system. And recently, I think like it's starting from 3 years ago from Android. I don't remember exactly the number, maybe R. They're actually the caching of the processes. So there's a processes that already was spin off. They're ready, but waiting for to be started. So actually, Zigud taking one of this process, returning process ID to the Activity Manager service. And what this Activity Manager service is doing is taking your application, taking all the classes that you need to load in order to use the app, and actually to bind them between loading these classes and binding between the process and the classes itself. And actually, it started your application. It's called for launch activity and call on your callback on create inside the activity. Basically, this is the first time when the user actually starts to see something on the screen. Very complex process. So when we want to start the new app and there's a available RAM, basically, you just load it, occupied part of the RAM, everything is fine. But what happens when we don't have enough memory? So like a bunch of other applications are running using our memory. So we click on the app, and what is happening is swap or kill. So what does it mean swap? So swap is basically, it's come from the modern PCs. All this multi-processing thing. So actually, what's happening when there's no memory available in RAM? So it's take the programs that you no longer use, but still open, and it's outloading them to the disk. Like take a piece of memory and put it on the disk. And when you come back to this program, it's actually loading it back from the disk back to the memory, to the RAM. And the thing is that on mobile, on Android, we don't have it. You know why? Yes, correct answer. So the flash memory, on Android, we're using flash memory for the storage. And there's a limited number of reading and writes that we can use. So if we're going to use it frequently, we're going to destroy our storage, right? So instead of that, we have this ZRAM thing. So ZRAM thing is actually like zip for RAM. It's searching for the all apps that less frequently used and try to compress the memory. And by that, like freeing memory to other applications to start. And if they don't have enough memory, then there is out-of-memory killer. So what is the out-of-memory killer and how it works? So remember, Activity Manager is the one, Activity Manager service is the one that's managing all the processes. So he has for each single of the process app, he has this score. It's called OM Edge. So basically, it's going from -50 to +50. -50, it's meaning this is the application that the user interacts right now. So like the lower number means that it's user sees something on the screen. It might be the activity, it might be widget, it might be notification. So there is a whole bunch of scores. And the bigger number, meaning this is the application that user less interact with, maybe it's probably all other components already killed, and they're just empty process that are sitting in the memory. So out-of-memory killer arrived, and he asked his Activity Manager, give me all these process IDs of the applications that are above threshold of 7 and use more than, let's say, 10 kilobytes of memory. And then you just kill those processes, and it's done. This is, by the way, remember, if you know from all documentation, it says like on low memory, on trim low memory callbacks, etc., etc. This is basically hook to this process of being killed by the system. So how it's connected to your app? Basically, it means that if your app is using less memory, it's likely to survive longer in the cache, meaning your user will get much fluent experience when coming back to the app. Why it's important? Because cold time, cold refresh, or cold restart actually takes more time, right? So you're loading more data, you're using your server, you're using the resource of the device, and also the experience is not really so good. So to survive, actually meaning you need to understand actually how all your code is working, right? So how it's related to the manager. So heap and stack, I hope you remember this thing from the computer science. But if you don't, I prepared slides for you. So this is the tiny code, very simple program, two methods doing something. Really doesn't important, but important what happened in the heap and the stack. So when we start this program, it's create in the stack the whole block of main is called, and then all references are going to be created in the stacks, in the primitives will create it there as well. So basically when we create, like for example, an integer, then it's going to be created on the stack. When we create some object, so the object itself going to be created in the heap, and our reference going to be stored on the stack. Then when we create another memory, another object like called memory, I don't know why dump, I call it memory. Then we have another call for the function, right? Print param with the object. So params become another reference to our object. String, so basically strings are allocated from the pool of the strings. And when our program is finished, like first method is finished, so entire block is just thrown away from the stack. And the main is finished, the main block with all references and all primitive types are thrown away. And actually, basically, what we left is with this allocated object sitting in the heap with no references. And to clean this mess, actually, we have something called garbage collector. So what's doing garbage collector? Basically, first of all, if you ever profile your app, you will see these tiny recycle bins. This is the garbage collector is working, doing something. And what is he doing? Be clear? Yeah. So it has two things to do. First is to find all objects that can be accessible from the roots and clean them. That's it. But the main catch is actually on what thread this entire process is happening. Any ideas? No? So it's happening on the main thread. Meaning, if our garbage collector is working very hard, it's meaning it's take time from our main thread. And this working hard is actually, there's a name for that. On Dalvik, it used to be called GC concurrent. Now it's in Art, it's called concurrent. And using this algorithm of mark and sweep, so basically, it's find this GC root. It's objects that considered to be roots of the program, and then it's try to mark all the objects that can be accessible from this root. So basically, there is a reference. And when it finishes, it's actually for all those that there is no reference, they swap it away. So basically, this is how the entire memory is freed up. So what is the GC roots? GC roots is basically a bunch of different references. So you remember all class loaders that classes that was loaded by class loader at the beginning of spinning the process. So there are the GC roots. Of course, all static references are GC roots. Local variables and parameters, they are also GC roots, by the way. It's very important. There are a lot of leaks coming out of it. Of course, new thread and synchronization monitor are GC roots as well, and GNI reference are GC root as well. So how to find those? Basically, when you profile the app, you can look on your reference to the object and see all bunch who is the one with the depth 0. So meaning that depth 0, this is the GC root that holding reference to your object. Basically, also I consider like to use shortest path because many different variables can hold your reference to the object. Like I say, you want to understand why this object is still in the memory. Use this shortest path until you find the one with the 0. So how these processes work, mark and swap. So in Android is actually doing in different stages. So first stage, as we said, is find for the GC root. And when everything is fine, it's happening concurrently. So basically, your thread is not affected. Your main thread is not affected by the GC. And then it's called mark reachable. So basically, trying to find all this that are reachable from the GC root and to mark them. And also, this is happening concurrently. And then there is a second pass of the mark reachable. So this time, this is the only when the GC actually the pausing execution of the app, trying to mark, to validate that all references that are marked as are really accessible, and is actually freeing memory, and it's happening concurrently. So if you will look into the log, for example, in Art, you will see that, first of all, there's a word concurrent. This is how you can identify it. And there, like actually, it took only 52 nanoseconds. So it was very fast, very efficient, amazing. But actually, what happened when we don't have enough space for a new object that we want to create? So there is a couple of things that are happening. First, it's called GC4alloc or alloc in Art. And it will try to free the memory. So it's going to pause everything, like all things that happen on the main thread, is going to find these GC roots, mark the reachable, and then free concurrently. And if we will look in our log, we will see that actually in this case, it was much worse. It took 102 milliseconds out of our main thread time, CPU time. It's like a crazy amount of time. We lost a lot of threads, frames, and I will show you why. And what happened when our heap is like full and we can't find the place? So we try to mark all this reachable, we free it, still there is no place. So we will have ended or large heap, so just heap will grow, or it will try to defragment the whole memory. So basically, you see these empty spaces between objects. So they just try to make the defragmentation in order to make the space for the new object. And what happened when we have another big object come into our heap? We don't have a space. It's dead. So entire process is going to be dead. Will crash with out of memory. So you see this crashes out of memory. You say, okay, what I'm doing? Actually, the funny thing that still, if you're going to Stack Overflow and you search for like how increasing the heap, what I'm doing about that, the number one answer about it, you know what's going to be? Any guesses? Large heap. Yes, and it's so frustrating. I was downvoting this question and it didn't help me. What does it mean large heap? It's meaning basically you will going to have larger heap, like twice bigger than in regular app. It's meaning that your GC pauses will be much longer. Okay, it meaning your CPU will waste time on trying to free memory twice of running of the main thread instead of rendering your application. So basically, it's mean your application will be more laggish, more less user-friendly, and more frustrating to use. So don't do it. And the first sign of like something is wrong in your app is actually you will see this bunch of logs in your logcat that's saying like waiting for GC, blocking concurrently, etc., etc., etc. This is the first sign something is wrong in your app. You need to start digging into why and what and how it's affecting your app. And why I care about memory so much? I mentioned a couple times about frame per second. So 60 frames per second is like, this is the gold standard, and I'm explaining why. So check this flipbook, right? Flipbook. So you see the animation here is not so smooth. We see this actually, this is just a bunch of pictures that changing one after another, right? And this is a flipbook is running with a frame rate less of more 12 pictures per minute, so 12 frames per second. Sorry, 12 pictures per second, 12 frames per second, right? We still notice that this is not smooth animation. Actually, the funny thing that all our today's movies that we're watching in the theater, they're running with a 20 frames per second plus some effects that help us to achieve this smoothness. And actually, the gold standard, the point where we want to be, is the 60 frames per second, because up to 60 frames per second, our eye can distinguish between what is the animation, what is the smooth animation, or just changes of the frames. And actually, for the gamers, who gamer here? Yes. So, you know the endless case after the better and better graphic card? Yeah, more than like, I have this like 100 frames per second. So here's the truth. Our eye can't distinguish between 60 frames per second and more. We just don't see it. So it doesn't make sense to buy more expensive graphic cards because there's no difference. Lies that told to us. So we want to be at this sweet spot of 60 frames per second. It's mean that we need to draw on the screen, to refresh our screen, every 60 milliseconds. So every 60 milliseconds, our CPU, our main thread, should be free to draw on the screen. Because otherwise, if we will have a garbage collector doing something and stopping our main thread from running, it's meaning we are dropping frames. And the first sign of that, if actually there is someone called choreographer from the logcat, I'm sure everyone is familiar with it because it's always there in the logs. And it's saying something like you are skipping X amount of frames, the application doing too much work on its main thread. And you know what the developers tend to do? They try to search for this thread or coroutine that's running on the main thread and try to fix it. But actually, in most of the cases, this is not a problem. The problem is that actually garbage collector that's running on the main thread doing some very long-running stuff, like trying to free the memory. And actually, this is a good sign that you need to stop and start to debug, understand why you are skipping frames, why you're missing them. So by now, I hope you get an idea. You need to do something about your memory. You know how it works, you know how it's affecting your app, but hey, where's the pitfalls? So the reason all this stuff is happening is maybe that there are a bunch of them, but mainly there are three categories. First, like you're doing a lot of allocations, but it's not about like don't allocate because we want to allocate things, we want to work. Actually, it's more about how to design for performance. And of course, there is a whole bunch of memory leaks. So the first point is like allocating, right? So you need to know how to allocate right. So for example, here, it's called something called memory churn. So basically, we have this tiny object called Hulk, and we allocated it like 1,000 of times. And we changed the reference, and it shouldn't be the problem. But actually, it's create a lot of pressure on the memory. It's caused GC to work a lot of times. So when you run this code, you will get something like this. A lot of GC, they're trying to, like you're creating a lot of objects, and GC need to work hard in order to clean this mess after you. So basically, you will end up your CPU like working so hard to clean the mess, like GC will work very hard, occupy your CPU, and you will see in the logs that your application paused like every second for half of a second, 200 milliseconds, 300 milliseconds. It's become unworkable. So when usually it happens, so I have this very artificial example, but actually it happened a lot in the production. So for example, if you're doing custom view, there is like mistake number one. When you're doing custom view, what you do in onDraw method is creating this paint object to use later in the canvas. But the thing is that onDraw is going to be called every 16 milliseconds, right, to refresh something on the screen. So basically, every 16 milliseconds, you're going to allocate this paint object. And actually, by the way, this is a very expensive object. For example, compose, right? How not about compose? Basically, composable function, you don't control how many times it's going to be called, right? It can be a huge amount of time. You don't know. So putting any logic, expensive logic inside of it doesn't make sense. It's just going to blow up your memory. List concatenation. So for example, here we have a list of Hulks. And like, for example, multi-universe, a lot of Hulks, and this amount of Hulks. So you don't really, so you can take this example to the buffers, right? So you read something from the network, from the file on the disk, and you don't know what's the size of the buffer, right? When it's going to be end. And what you do is actually you're concatenating, like you take one list with the things that already been loaded, and you load more. So basically under the hood, you created more and more and more lists, and they copy the entire content, and it's like very affecting your memory. So basically, this is the memory churn. So good practice is actually, when you have a stream of data, think really, really, really cautiously, should I do something about it? Like how properly write the code not to affect the memory? Better to allocate things outside of the loop, reuse some like kind of pool of the objects, and actually to think that, do I really necessarily need to do this in this structure with a list? Maybe I can do something else. And the second thing that you need to know is actually to think what's happening under the hood in those libraries that I'm using, right? Because it's not only about your code. It's also about that code does not belong to you, but actually running in your app. So for example, Room, we're using Room nowadays, Android Room. Okay, whoa, a lot of us. So it's a very popular framework, right? So here we have DAO interface, very simple one, that like querying items. And we have this observation method. So we're using Kotlin coroutines flow to observe every changes in the DB. Right? So for example, the user loading the screen, list of the items, and we want to observe changes in those items to be very reactive. Really like it, we're developers. And we build this query like select star from items table, and we're returning back flow that everyone can subscribe. So basically, what's happening under the hood is actually up until our coroutine that subscribe to it is active, the entire list of items stays in memory. Actually, I don't know if it's like bug or not. I opened an issue tracker bug about this. I don't think it's right, but this is how it works today. So if you have this coroutine, so for example, you create repo, singleton repo, and you observe for these items, basically those items are going to stay in your memory forever. And when it's small, it's good, but let's say you have 3,000 of items, like in our case, it's become mess. Like how you solve it? It's like just putting this chunk of the memory, chunk of the items inside of memory, and like that's it. The memory is full. So what you can do about that? Well, pagination. Always, when you have a list, like you have this keyword list, you need to use the pagination, especially when you don't control amount of data that can be arrived, right? Because most of the time we're consuming the data from the backend, and then it might be 10 items, but it might be 10,000 of items, and can blow up your memory. So you need to protect yourself, use pagination from the day one, make your life much easier. JSON. I think, like, who is using JSON today? Yeah, most of us. But here's the pitfall. Let's say I have this request with a body of 1.5 megabyte, right? So JSON is an amazing library. Like, it's very easy to use, like 4 lines of code, and you can serve requests in the request to your app. But the thing is that JSON storing the cache of all mapping inside your RAM, inside your memory. So basically, for this 1.5 memory, 1.5 body, it's created almost 1 and 2 megabytes of cache. What? Why? So probably the intention were good. Downside of that cache is actually staying in the memory, holding this piece of memory, chunk of memory, and make the things more frustrated. So probably you want to consider using Moshi instead. Actually, for us, it was like about 60% of memory reduction after we switched to Moshi. And I can endlessly talk about different libraries and different improvements, but actually, at the end of the day, it's a lot about profiling your app. I know, besides like clicking this button on profiler, memory, and start to dig it, there's gotcha moments that actually took me a while to figure out. So when you see in the profile, there's 2 things: shallow size and retained size. Right? And for me, it was very confusing how it's work and why it's different. So shallow size is actually basically counting all references in the object, like references itself, and the primitives that's inside the object. And the retained size is basically the same as the shallow size, plus all objects that are references from this object in their size. And it's the shortest path. So I'll show you the example. So here we have the empty object. It's like completely empty, nothing inside. So we have this like just 8 kilobyte, and we don't referencing anything. So shallow size and retained size are the same. Let's take Bruce Banner, right? And Bruce Banner inside of it has Hulk, right? So basically, Banner referencing Hulk and all other bunch of stuff. So we see that Banner, the shallow size is 20. So all our inner objects and references of the Banner. But retained size is 36. Why 36? Because it's referencing Hulk, and Hulk itself shallow size of 16. So 16 plus 20, 36. So this is how you can find all this memory that it consumed by who and why, what's the difference. But there is a gotcha moment in that, the shortest path. So if I will change my code in this way, so basically I will save Hulk as a reference of our outer class, like the hostess class, then our banner no longer going to count as retained size the size of the Hulk, because the shortest path to our Hulk is not from the banner, but from the hosting class. And this is actually an important moment that took me a while to figure it out. And the last thing is leaks. So we had a bunch of talks, even one before, about leak memories and how to use leak canary. So I'm not going to bother you about leaks. But actually, if you don't use leak canary, start using it. But the thing is that, for us, we integrated leak canary, and for a long time it was staying on our device, right? So what developer that in a rush was developing different features, fixing bugs, do with this notification about new memory leaks are found? But you know what he's doing? He's just dismissing. That's it. Leak is fixed. So it's like, for me as a leader of the group, it was very frustrating because I knew that there is a problem. So it also was very complicated to debug it, right? So because it happened on the device, what were the logs, what you were doing before, how this leak has occurred. So what we did, we actually decided to integrate between Leak Canary and Crashlytics. So Crashlytics is a great tool. It gives you visibility of what's happening in your app, not only about the crashes, but also of everything that you're going to report in it. Right? So what we did, we started reporting all leaks that happen on our devices from our test farm to Crashlytics, and we will actually, basically, for the first time, we got a picture how often it's created, how many memory it's occupying. It's what's happening. And to do this is very, very simple. Is actually, we have this config in our Leak Canary, and we can take it, copy, take all event listener, and just add our analysis upload listener. And this is very simple event listener that is receive the events, and if the events of heap analysis succeed, then we can take heap analysis and upload it. Because it might have many leaks, don't take a picture. I will explain why. Don't take. So we can take the heap analysis, and because there are many of different leaks that can happen in one heap analysis, you just create this list, you map from the leak to the trace, and their gotcha moments is that you take this trace and you convert it to the exception. This is how we can send it to the Crashlytics. So we convert it to fake exception, you add additional parameters, and you send it to Crashlytics, and you achieve this. So basically, you get all these references, all logs of this session, and what happened on the device. Of course, it's not full code, so if you want the full code, I will publish GIST on my Twitter. Yeah, so you need to follow me. I told you, don't take pictures. So, we're almost over, almost done. Yeah, mine was mine. So, we're almost finished. So, leaks, behind the obvious ones like static references, anonymous class, etc., there are some gotchas that you need to learn, and it's actually complicated things. For example, when you're using long-living class, right? So, for example, singleton that have this reference to the context, they take this context and want to use system service like connectivity, right? And actually, behind the scenes, when you're using activity context, for taking a system service, you're actually taking this and connecting between the system service and the activity itself. So you're leaking activity. So instead of this, use application context, just small things, solve a lot of huge problems. And I think the last one, taking this view model. It's a very simple one. You have live data, right? And then you have this observe function that take lifecycle owner and observing on the live data and calling back. Very simple, trivial code. And then in your fragment, you take this view model and you observe with this. But this is actually a life cycle of the fragment. And the thing is that it's a very bad idea. Why is a bad idea? Because this is the fragment. Fragment is not necessarily view. So when you will get the callback about updates in your fragment, your view might no longer already exist. The fragment is dead, but your view is dead, but the fragment still might exist in the memory. So you might be able to get the updates. So instead of that, use view lifecycle owner. Very small things, but somehow people are still get confused. Not somehow, it's very tricky to get your hands about it, and a lot of people get confused. So by now, I hope you learn a little bit of memory. You learn about how to improve your code, how to profile, and what common mistakes in the leaks. At the beginning, it's especially for me, it was gosh, how I deal with this complex application with a lot of memory leaks, how I profile, how to understand where the things are going wrong. But the thing is that if you will take this comfort zone out of yourself and you will start to deal with it, actually this is what's going to make you the best developer out there. because you'll understand how the profiler works, how the CPU works, how the garbage collector, you understand these bits of bytes on Android, and this will make you a badass Android developer. So thank you, everyone, for listening. I wish you all happy users, 99.99999 crash-free rate in your Crashlytics, and thank you.